Hello and welcome back. We're going to do one more lesson on multiple regression analysis because even though this is an introduction, we're kind of doing the 40,000 foot view of multiple regression analysis. There's still something I've just got to show you, and it's called stepwise reduction because there's kind of something I left out in the last lesson. I'll show you what I mean. Come on. So in the last lesson, this is what we were working with. We did a multiple regression analysis on this startup company using number of calls and years of sales experience to determine how many meals would be sold. And when we looked at the individual variables, we found that each had a p-value below 0.05. And I said, well, that's good. But what if the p-value isn't below 0.05? That's what we need to address in this lesson. And to do that, we're just going to start a whole new story. So the dean of the business school at Colorado Technical University is applying for grant money to fund his data analysis program. And as part of his grant application, he wants to be able to estimate the final GPA of students finishing his program. So the variables he thought that would contribute to final GPA were, well, high school GPA, SAT verbal scores, and SAT math scores. He surveyed 9 former students and found the following data. So let me show you what we're going to do. Okay, so last time I showed you stats.blue to do multiple regression analysis, and that's what we're going to do. I actually went in and plugged all this in to the linear regression calculator, and it came out with this output. So with just a quick glance, let's look at the summary and see the goodness of fit. We've got an R squared of 0.86. Okay, that's good. 0.38 is the standard error, not bad. And an overall p-value of 0.01. So with those numbers, we know that, well, something significant is going on. So now we're going to look at each of the individual variables. First thing we're going to do is identify any that have p-values below 0.05. Here are the p-values. And let's see, the first one below 0.05, the second one is not, oh, and the third one is not. So we have 2 that are not below 0.05. So we're going to identify the highest p-value, which in this case is x2, which is the SAT verbal. We're going to take that one out, and we'll rerun the regression without that variable that has the highest p-value. Now you can only eliminate one variable at a time because when you eliminate a variable, it can change all the numbers. So don't get too eager and just take it a bunch. Be patient. So I've rerun the regression without SAT verbal, and here's what I have. Same process. I'll identify any p-values below 0.05. So again, x1, really low p-value. x2, still above 0.05. Identify the highest p-value that's above 0.05, and we're going to take that one out. And I'll rerun the regression without that variable. Now at this point, it's not multiple regression analysis anymore. So if I go to stat.blue, I don't want to use multiple linear regression because I only have one variable. So I'm just going to do a simple linear regression. And they have a calculator for that too. I just plug in the information I know, hit enter, and I come up with this lovely output. So my final regression line then is y equals 1.16 minus 0.45. I've got an R squared of 0.83 and a correlation of 0.91. So good numbers, let's take this for a test drive. If someone graduated high school with a 3.5 GPA, what would be that person's likely GPA coming out of the CTU data analysis program? Here's our regression equation. We plug in that GPA of 3.5, and we get a likely GPA graduating from the CTU data analysis program of 3.61. So let's just do an overview now of multiple regression analysis using stepwise reduction. First thing we're going to do is, well, run the regression. Then identify p-values that are below 0.05. We need to keep those. We're going to identify the highest p-value that's above 0.05 and run the regression without it. We'll repeat until all p-values are below 0.05 and then just analyze the final regression as normal. So many things you can do with this. Thanks for being here.